tool improves the way you work, a great tool improves the way you think. So that's a quote by Nate, as far as I remember. And serverless containers, at least in my opinion, are surely that tool that will improve the way you think. So it's a different way of thinking of how the cloud works, like what infrastructure.
We can't hear from here.
Yeah.
Sorry, this is easy.
Yes.
Thanks. Yeah, so serverless containers is a good tool that actually makes the way you think better, and that's what I'm going to talk about today. I am Geshan Manandhar, a senior software engineer. I call myself as a tech solution provider. I am a Google developer expert for Google Cloud Platform since 2019, I guess. Yeah. And I am one of the Gcloud Sydney organizers as well. So if anyone is here from Sydney or wants to give a talk at Sydney, talk to me. And I've been blogging since a while. You can see the URL geshan.com.np there. If you want to follow the slides, probably it's easy to just scan the QR code if you just want to follow the slides while I'm speaking. Yep. I am originally from Kathmandu, Nepal, the only country that has a non-rectangular flag and 8 out of the 14 highest mountains in the world. Apparently, it's pumping around $4 billion to the Australian economy with all the students pouring in. Just a quick show of hands. How many of you actually identify yourself as a Nepali? Not bad, not bad. Thank you. Yeah, and I work with Simply Wall Street. We help individual investors make confident investing decisions on shares. So basically, this is a platform that visualizes a lot of stock and share related data. Regarding what we're going to cover, I'm going to cover today is what is serverless containers and why use containers. Then I move into the current serverless function as a service offering, then the cloud spectrum, a bit about Google Cloud Run, a demo, and some projects that actually use Google Cloud Run in the wild. Let's start with what is serverless. Serverless could mean multiple things to multiple people, but mostly people understand serverless as function as a service offering. Yeah, I mean, like the tech industry is not very good in naming stuff, I would say, and the same goes for serverless. But then backend as a service also qualifies as serverless, where Microbots from Symphonia says it's a fully incorporated third-party cloud-hosted application and services. There are things like AppWrite and others. For instance, Firebase can also be considered a full-on backend as a service, and that's also serverless, right? So if you think a bit deeper, for instance, something like S3 is serverless. You are just paying for what you use. You don't have to maintain any servers. So serverless is a much bigger realm than just function as a service. That's what most of us are kind of pushed or highlighted about. Basically, function as a service is that you can run your stateless compute containers that are event triggered, ephemeral, and it is fully managed by third party. For example, your Lambdas, Google Cloud Function, Azure Functions, these are functions as a service. But that has been like the main highlight of being serverless. As soon as you hear serverless, you kind of automatically gravitate towards thinking that only function as a service is serverless, but there are other facets to it. One of them is surely serverless containers, which I'm going to dive in deeper. So why use serverless then, right? What's the whole point of using serverless? There are some good reasons to use serverless. The first one, of course, being there are servers, but you are not managing them. Basically, you're outsourcing it to the cloud provider to just get everything working. It is precisely cost-based. That means the more traffic you get, the more money you pay. But on the other hand, you only pay by the second. For instance, for the whole 24 hours, if there was traffic on your website for only 15 minutes, you're basically paying just for those 15 minutes, right? That's a very good thing. Another thing that's good about serverless is it's inherently scalable. You are not worrying about scale. Like a Lambda function, I think, could easily handle 1,000 requests per second without a glitch. So as long as you can hit it with load, you don't need to worry about anything. You don't need a DevOps team that is looking after it. As long as you can throw the code over the wall, the cloud provider is basically handling all the scalability. Similarly, high availability is also given because it's the big clouds handling it. they have provisioned enough machines for it, so it is implicitly highly available. Another good thing for you as a developer is it is quick to deploy. As long as you can just deploy your code, it's basically working. So that means reaching to a working application is much faster and you have a better time to market. Before I move forward, how many of you identify yourself as backend and or DevOps engineers, backend engineers? That's good. So there are more reasons to using serverless. You could visit the URL. Basically, Forest Brazil talks about security and other stuff. I mean, the more you outsource, the less you need to think about it. That's basically serverless. What happens with this is you can focus more on the application code and the features that you want to deploy rather than the infrastructure, the number of servers, nodes, Kubernetes, memory, CPU. I mean, just push that away to people who know to do it the best, which are the cloud providers, and focus on your code and your application and the features that you want to provide. Now, in terms of VAS, of course, in the big three clouds, there's offering like AWS Lambda, which I already mentioned. Google Cloud has Google Cloud Functions. Similarly, Azure has Azure Functions. But depending upon the type of platform that you're talking about, for instance, you might not be able to run Rust on Google Cloud Functions. But if you need to run anything that's more than 15 minutes, probably serverless is not the way, or function as a service is not the way to go. Generally, like serverless functions are triggered by events. For instance, you upload a file on S3 and then it triggers something. For example, if you have a very big image and you want to resize it as soon as it is uploaded on S3 or some other bucket, then you could put a serverless function on top of it, like listening to that upload saying, yes, if it's uploaded, maybe I get like a big 5 megabyte file, then it would make it into, I don't know, like 800 by 800 pixels that is more web friendly. So things like these can be very easily done with function as service. Similarly, you can see the memory limits and things. But the main thing that I think you need to think about here is, I don't know, if one run COBOL, for instance, there is no way to do it in one of the function as service, right? So I think that is one of the major things that you need to think about. This is the hype cycle from Gartner, 2022. So from here, you can kind of see that it is time to adopt serverless function platform as a service. So it says plateau will be reached within 2 to 5 years, well, less than 2 years for the white one. So serverless functions platform as a service, I think it's a pretty good time to use it. It's tried and tested. It's been years that serverless has been around. So probably it's a good time to give it a go. Similarly, serverless infrastructure, they believe will be plateauing in around 2 to 5 years, right? So that is also something I think that goes aligns with what I'm going to talk next. But yeah, I mean, as long as we are saying there are no servers, there are no servers, actually there are servers. Yeah, the only thing is you are not managing them. You are just pushing it away to the big cloud providers. They are giving you the slice of that server for the amount of time that you are using it. But it's not that you don't have servers behind. You actually have servers. It's only how it is given to you or how you are using it. And that's the main idea behind being serverless. Now let's go into what containers are. Who here knows about Docker or has used Docker? Yeah, probably half of it's good. Yeah, so if you hear about containers, they have kind of become synonymous with Docker at this point, even though Docker is not the only way to do containers, but of course they are the most popular ones. And straight from Docker, they say it's a standard unit of software that packages code up code and all its dependencies. So the main point here is all its dependencies, so that applications can be run reliably and quickly over any computing environment. So that's what Docker and containers is all about. Now you might think you have serverless, you have A, you have B, you have virtual machines. You might have come from the days of Vagrant. So why is serverless, right? These are some of the good reasons that you should B, why use containers? These are some of the good reasons why you should be using containers or Docker. As the definition also said, you're shipping the whole stack. By that, I mean, you're shipping your code, third-party code, probably even the OS, because it's all packaged up into the same packaging system. So as you are moving the whole stack, there is less chances of discrepancies, and if not fully, to a point, you will get over the issue of runs on my machine. Basically, if it runs on your container on your local machine, 99% of the time, it should be running on staging or production, unless there are like big discrepancies. The other good thing compared to VMs in the past is it is pretty resource efficient to scale up containers. Potentially, you could be running, I don't know, hundreds of containers easily on this Mac. But I don't know, if I run five VMs on this Mac, probably it's going to blow up. So that's like a very simple distinction between that the resource utilization is done much better in containers. And that's where you can scale them horizontally across nodes or across machines much easier. And as I said, the initialization is faster compared to the older technology, if I can say, basically the VMs. So that's one of the things. And as soon as you start using containers or running them on Kubernetes, at least your workload becomes much more cloud agnostic. For instance, if you are on AWS and then you want to move into a cloud platform, which could be a case, it is much easier because what you are doing at the end is running containers, scaling containers with something like Kubernetes. So as long as any cloud provider can give you the right Kubernetes or the right flavor of Kubernetes, you're still running containers. If you really need to move clouds and or have a multi-cloud strategy, it becomes a lot easier with containers. But this is something I think is not talked about much, is the dev side of things, where a developer could be very productive on day one. By that, I mean, from the Vagrant days or even earlier, I used to work for an e-commerce company, and there would be 3 or 4 applications that would need to be set up locally so that I can be productive, right? And not only the application, maybe it'll have some data store or like databases behind it. Now, I don't know, 7, 8 years back, when someone would come in on the first day, at least half of the day, they would just be setting all of that, the right version of PHP, the right version of MySQL, the right version of Solar and everything, and make sure that everything works together properly, and then only they would be productive. But with serverless and with containers and with Docker, what they could do is they could just clone 3 or 4 repositories, go into them, and then run a command like docker compose up, get a coffee, and if everything is fine, the application should already be up. Or if everything is packaged in together, probably it's just one repository that they need to clone, go in, run that docker compose up. Yes, like downloading all the files will take some time. And yeah, they could potentially deploy to production even on the first day. So at the end, like using containers is basically decreasing the distance between dev and ops, which is also called probably SRE by Google, right? So you can focus on the main things, which is trying to get more productive while leaving other things behind. But, and a big but, these two camps have kind of been fighting that there has been tribal wars between that. Even now, if you go into Google and search serverless-based containers, the first suggestion I think you get is serverless versus containers. So there has been like a raging battle between these two camps, and Forrest Brazil has even put up a full-on rap battle comparing serverless and containers. But this talk is not about comparing them. It's about getting the best of both worlds, making a bridge between these two worlds, and just trying to get the best things from both worlds you can get and apply it into your application. Now, serverless and containers, the evolution in the cloud, what has happened probably in the past 10, 12 years. The two main things that you need to consider here is the control that you get when deploying something and the ease or abstraction that you get when deploying something like containers or functional service. I don't know, like 12, 15, or probably even more years back, the main thing came in was virtual machines. Before that, people would actually buy physical servers, rack them up, right? And then later what happened is they knew that even if you get a very powerful server, you could run, I don't know, multiple basically slice the resources and run multiple virtual machines on them. That was like the first beginning of some form of virtualization. Later, I think, I don't know, it was 2013 or something, Lambda came in, and that was serverless functions, function as a service, where you have a lot of ease and abstraction. The only thing that you're doing is you're throwing the code over the wall, and then it's running. But then what you lose upon is control. You cannot go in and SSH into that machine and check what's happening, like how much memory is it using or doing anything. Compared to that, in a virtual machine, you have full access. You go in as a root user and potentially check or change anything that you want. So later, what came in, probably Heroku was one of the first ones, was platform as a service. Pretty similar, you still throw the code to them and they would run it. You had a lot of ease, but maybe lesser of the control. And one of the things was, I think, most of the Ruby on Rails app that was thrown over Heroku was costing a lot to the companies after one point, because they would control whatever they had and they could charge you whatever they wanted. Yeah. Then I think 2014-15 containers came in. As they say, the future is already here, but it's not spread, like it's not available to all. Containers wasn't like a completely new thing. Very big organizations like Google and others were already using it internally, but it was not democratized as such. That's where Docker came in 13-14, something like that, 13-14, and it just made the idea more popular, more accessible. Yeah, so I think we could easily say Docker came in and democratized the use of containers from bigger organizations to middle and smaller organizations, giving it a better interface. Now, my belief is serverless containers sits in the middle, where you're actually running containers, and you also have the ease and abstraction of not needing to manage any of the infrastructure. So basically, you are just running containers and only paying for when you run it. By that, I mean, like, let's say if you have a COBOL app, again, coming back to COBOL, and you could package it as a container, you could run it serverlessly. Now let's enter Google Cloud Run. Google Cloud Run is not the only platform to run serverless containers. Apparently and supposedly, Fargate and Azure Container Instances also run containers serverlessly. But then there are like things that you could point out on, do they actually run it like serverlessly, and can they actually scale when you need that? I guess that would be another discussion that we could have. Anyhow, Google Cloud Run is a managed compute platform that actually scales your stateless containers. Stateless also might be subjective at this point. And it basically abstracts away all the infrastructure management from you. The only thing that you need to do is focus on your code and building great applications. Towards the end, I'll have a demo where probably 2 clicks, not 2 clicks, 1 click and some enters, I would be able to get a URL for a code I have. So why use Google Cloud Run compared to other offerings, or just in general? With Google Cloud Run, there would be no need to learn a completely new paradigm or framework. By that, I mean, if you put your currently running application or transform it into function as a service, you need to know the nooks and corners of that particular thing. You need to know, like, it is completely stateless. One request actually spins up only one container probably at the back, and then runs your application. So there will be some extra learnings that you need to do. And with Google Cloud Run, as long as it can be containerized, it can be run in a serverless fashion. The next thing is that you can run any language or framework or binary, again, as long as it is containerized. So there are no fixed runtimes. For instance, if you want to run, I don't know, like Python 1 app that you are not able to upgrade, that's possible. You just containerize it properly and run it. I'm not saying do that. Probably you have like 100 security vulnerabilities there, but if you really want to do it, it is possible. Yeah. Similarly, it is fully managed by Google. The only thing that you need to do is containerize it, push it across. Google runs it. Actually, if you don't want to containerize it, there's a thing called build pack, and you can actually just push your code and it will just run it, package it up as a container and then run it. For instance, you could just run a Node application without even having a Docker file inside it. And yes, Google Cloud Run can also do that. You get HTTPS URLs directly out of the box. You don't need to do anything. You don't need to configure any of the certificates and stuff. Similarly, you can also get custom domains, for instance, myapp.mydomain.com. Very easy, go into the interface, just configure it, link it correctly with the DNS, the Google DNS, and then your custom domain will be pointed to your container running on Google Cloud Run. And the other good thing is you'll be able to leverage all of the Google Cloud toolset, for instance, Cloud Build, logs, and all the other things that Google Cloud provides. More on this, you can do amazing things with Google Cloud Run that is pretty difficult to do with a standard Kubernetes cluster. For instance, if you want to send 5% of the traffic to this new revision or release with Google Cloud Run, that's very easy. You could just do it from the UI. It's a lot easier than, like, I don't know, configuring something like Istio or some other forms of traffic manager. Similarly, you have concurrency and you have control over the concurrency. One container could handle one request or up to 1,000 requests. That's up to you. You can decide how many requests do you want that particular running container to handle. So concurrency is also a configuration. And then you could just go on serverless. By that, I mean you have minimum instances as a configuration again. So let's say if you set 2 as the minimum instances, 2 containers will always be available. They will not go down, even if there's no traffic. But then it's as long as it becomes not serverless, you are paying for those resources. So think of what you want to do. Getting from 0 to a working URL is very easy. Yeah, I'll have a demo about this. And yeah, like recently, Google Cloud Run has added new features like jobs. You could have cron jobs on it that could run for a long time. So those things are there. There's integrations with things like Firebase, Cloud SQL. So if you wanted to connect to containers to these services, that is possible. The other thing they have added recently, or probably it's still in beta, is the use of sidecars. How many of you know the idea of sidecars in containers? Yeah, like, so basically it's like you have your main container. In Kubernetes, the collection of containers is known as pod, and the service sends traffic to the pods, right? So that's what it is. And a pod is not necessarily just one container, it could be multiple containers. For instance, if you have your main container as a web service and then you want to ship the logs to, I don't know, somewhere like Datadog or something, that could be taken out of the main container and could be put into another smaller container. That's a sidecar container, which could just manage the logs for you. Google Cloud Run also has all of the CI/CD goodness that Google Cloud provides. Bitpacks, as I already said, if you don't want to containerize your app, you could just throw it over the line, and hopefully the right build pack will take care of it. Like now it has startup health checks, log metrics, and all of these things already built in. You don't need to include any new packages to actually have monitoring and logs for Google Cloud Run containers. Yeah, if you want to know the latest, you could just follow the release notes, and yeah, you will know about all the new things happening in Google Cloud Run now. Yeah, so basically at this point, if you can use servers and containers together, it's bliss. By that, I mean, especially if you are a startup, I would really suggest you to try this, because you don't want to like have 1 or 2 person doing DevOps and or infrastructure management. You can just focus on your code, get it across, and it's running basically. And now let's have a look at, hopefully after praying to the demo gods, let's have a look if it works. So yeah, this is a repository, a Google GitHub repository, open source. It's a very basic app that talks to a database and shows you some codes, nothing out of the ordinary. Talks to a Postgres database, and that's it. Let me try to deploy it on Google Cloud Run. So there is this thing called Google Cloud Run button that you could add in your repository, and yeah, anyone could try it. So hopefully things go fine. This is the Google Cloud Editor, and right now it's just provisioning my Cloud Shell. And it'll just run some commands, get that particular repository, and yeah, we should have the API running. Let me do this for the people at the back. Yeah, so now it's asking me which project would I want to put it into. This is my favorite one. Yeah, it's trying to turn on the Cloud Run API, which should already be on for that particular project. Yeah, US Central, the default one. Why not? Just asking me to pick the region. And now what it's doing is basically doing the Google Cloud, the Docker build. It already has a Docker file, and it's just building it as a container so that it could be pushed. It's already pushing it, as you can see here. It just pushed it into Google Container Registry. Yeah, it's using Container Registry at this point, not Artifact Registry. Now it's doing the deployment. Cloud Run deploy, blah, 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 this platform managed. Of course, Cloud Run can also be run within Anthos, so that would become within your own network, but let's not go into that territory. Right now, what I'm talking about is the managed Google Cloud Run. You just give it the container and it runs. Allow unauthenticated, yeah, this means that let the unauthenticated public traffic actually be able to get into the container, and there you have it. I have the URL for this. Hopefully it works. And it does. It's alive. Boom. Yep. So yeah, this is actually going into a database and then pulling all of these codes. So it's not that slow, I would say. Okay. So this is how easy it is if you just want to deploy a code once. But if you want to do a full-on CI/CD pipeline, that is also a possibility. If you can go to this, I've already shared the slides, right? Yeah. So if you go to this and then have a look at the cloud build file, there's a way to do like a full-on CI/CD. That's what you need. So this is gonna build the container on every change, and yeah, you could do that as well, and then deploy it on Google Cloud with a full-on CI/CD. That is if the demo gods did not listen to my prayers, I had a backup. Now I do run some of my side projects on Google Cloud Run. One of them is Nepal News English, which is a Twitter bot that has 50,000 followers. Probably it's dying right now because of all the restrictions X has on their APIs. Let's not go into that territory, but yeah, that was one of the things that would go in and pull news from these sources, 40, 15 sources, and push it on Twitter, which has like 50,000 followers, but probably not many updates these days. Not because of anything technical, but because Elon Musk and X decided to restrict the APIs to a point that it is basically dying. Yeah. The other side project, the project that we run is avtechjobs.com. That has around 1,500 registered users, and it basically aggregates jobs from 70 plus companies. Currently, it should have around 1,200 plus jobs. And yes, in this slowdown market, probably you would just want to check that if you are looking for a new change. The last project that uses Google Cloud Run that I know of, it's not a side project, but it's only on Dev, is a website called OHC Guide, which basically compares health insurance for EU residents and international students. Some other hyperscalers that actually use Google Cloud Run are Mailchimp. They use it to scale their web services. And yeah, they have the ability to put automatic scaling service in production with just one command. That is what they find attractive about Google Cloud Run. BBC, this quote is from one of the blogs on Google itself. So when the Queen passed, that is when this happened, that they were running like around 150, 200 containers, but because the news spread like wildfire of the Queen passing, they were able to scale like 5 times from their general load, and they say that it worked, it just worked. Yeah, so that's the power of scaling up with Google Cloud Run. Similarly, Hermes is a e-commerce website, and they said like 99.8% of the things were fulfilled, and their whole website runs on Google Cloud Run, which has around 30 microservices. Yeah, that's me. Thank you, and open to questions.
Any questions? Stop them all into silence.
Great. You can connect to me on LinkedIn if you want.
Cool one. Thank you for the talk. I think you briefly mentioned that there are serverless container offerings from other cloud providers as well, but there are some nuances to how they're different to Google Cloud Run.
Yeah.
Can you sort of touch on that? What do you mean by that?
So I've not used them much, but as far as I remember, and is there are like two things. One is the scaling part. I think Fargate is kind of good at the scaling part, but ACI, Azure Container Instance, is not very good at the scaling part. Whereas I think Fargate, what it does, it actually runs the containers. They are not really serverless, and you kind of have to pay for it more. Whereas ACI does not really run it when there is no load, but then it is not very good at scaling. But all of this is what I've read. I have not actually gone in and used these services to have any proper opinion on it. But yeah, I found Google Cloud Run to be a pretty good one. That's one there.
Thanks, Geshan. This is a little bit more about containers specifically. Wondering if you've seen like a high level or like large scale in an enterprise somewhere where they've solved the problem of having Windows and Linux-based containers running, and how that has worked if you've seen it.
I have no idea, being very honest. At least the two places I have worked with, we only had Linux containers, and that was pretty okay to run. I don't have experience with Windows containers. I know like you could run like .NET within a container, but I have no experience with Windows containers.
Any other questions?
While the question is coming. So yeah, it's been 30 minutes and I have not said the word AI. So before that, before taking your question, if you want, you could do something like this, that you could create a web page where you can actually use Vertex AI and then ask questions to any web page that actually uses Vertex AI. And I tried it with Google Cloud Run and I was able to run it. Sorry, you can go ahead with the question.
So,
Switch on the side.
Go ahead, sir.
yeah. So can we? Is this statement true that all these services, Cloud Run, ECS, with Fargate or Azure ACI, these are kind of providing abstraction layer on top of using Kubernetes, because directly using Kubernetes is very painful. So these are like giving you easy way to access Kubernetes. Like, is this statement true?
I would say yes. I would say generally yes, because if you have Kubernetes and don't have at least one DevOps or SRE person in your team, you're probably going into a much difficult position, right? So with Cloud Run, something like Cloud Run, you could potentially, without a DevOps or SRE team, use the goodness of the Kubernetes, because it is still Kubernetes with Knative on top of it, but not needing to thinking about what's behind it. As long as I throw my containers to you and you can run them, I'm good. So yeah, there is a question there, right? No? Okay. Then sorry,
I think we're all good with the questions.
Good, yeah. So this is something if you want to use. This is built on Cloud Run. What I did was I just copied one of my blog posts and put it here, and it does a summary to it. And I could actually ask questions like this. Yeah, it says Fargate is not good. That's it.
Thanks very much, Geshan. Back up to you.